So let's look at some examples of these square roots. The directions that you'd expect to see on a problem like this is simplify the following square roots or simplify the square root. So the first problem here is square root 36. We're just being asked what number times itself equals 36. And so our answer here would be 6. Now, one of the things that you want to kind of think about when you're looking at any sort of new mathematical idea that you're studying is to say, what happens when I look at positives? What happens when I look at negatives? What happens when I look at zero? What happens when I look at fractions? And so that's really what we're going to look at here in these next couple examples. We're going to try to hit on each of those different topics to say, how does this behave with zero? Can I take the square root of zero? Is there a number that when I multiply by itself it equals zero? Sure, 0. 0 times 0 does get me 0, so taking the square root of 0 is a perfectly well-defined value. Now for C, if I want to think about multiplying something by itself to get this fraction 4/49ths, I got to think about how I multiply fractions. That if I have a fraction times a fraction, I just multiply across the top and multiply across the bottom. And so what that tells me then is that I can simply take the square root of the top and the square root of the bottom separately and get an answer of 2/7. Because if I would have multiplied 2/7 times itself, I would do 2 times 2 and 7 times 7. So taking the square root of 4/49ths does in fact get me 2/7. Now I want to look at D and E here at the same time. These are two very different problems that are asking two very different things. And so I want to identify what's going on here. Now example D here, the part D, is kind of like what we were looking at in the intro to this example to say, I can take the square root of 81, like if this negative sign wasn't there, I can take the square root of 81, and that's a 9. And then that negative is really saying multiply your answer by -1. And so if my answer was 9 and I multiply it by -1, I get -9. Perfectly fine answer. Now, E, on the other hand, is asking a different question. This is saying, I need a number that when I multiply it by itself, the answer is -81. Well, if I were to multiply a positive and a positive together, the answer would be positive, so it can't be that. What if I multiplied a negative and a negative together? Well, the answer is also positive. So I can't multiply a number by itself to get a negative answer, at least not a real number. And so that's actually how we want to answer this, is not a real number. Let's actually write number in there. We're not going to say no solution, because we're going to learn later in this unit, there is a solution. There is something this simplifies down to. It's just not a real number. It's what we call an imaginary number. We're going to define what that is and how to find it a little later on, a few more lessons from now. But for now, we're just going to say, hey, it's not a real number.